Welcome students, we've been given this question to find the Laplace inverse of s over s squared positive 1 raised to the power of 2. Of course, I've already explained to you that questions of this nature can also be solved using partial fractions, but the only thing is that it is very cumbersome. So for that, we would have in other words, we would have to resort to an easier technique, what is called as convolution. Now, we have been embarked on this particular topic of solving questions related to Laplace transforms, specifically inverse Laplace transforms, using convolution concept. Now, just to have a recap, now if you have two functions, say f star g of t, and you have two functions and you are convoluting these two functions, then you got this convolution of these two functions to be represented as integral 0 to t, and this is going to be f of t minus u times g of u times du. Now, since convolution is commutative, you can also have the reverse of this, which I've already explained to you. So for this question, I would be using this convolution to obtain the solution. Now, to start off, what we have to do is we will have to split this given Laplace inverse. So I'm going to rewrite this as L inverse of 1 over s squared positive 1 times s over s squared positive 1. Now, s squared positive 1 times s squared positive 1 will give us s squared positive 1 raised to the power of 2. 1 times s will give us s. So it's just writing it as a product. So there isn't any convolution appearing here. But if I rewrite this as L inverse of 1 over s squared positive 1 asterisk L inverse of s over s squared positive 1, now comes the convolution. You have to understand that convolution is not product. We call it as asterisk. That's it. Now, L inverse of 1 over s squared positive 1, or in other words, L inverse of 1 over 1 positive s squared, this is going to be my sine t, and that is convoluted with s over s squared positive 1. You are taking Laplace inverse. This is going to be my cos t. So you have two functions. So you got this as f of t star g of t, which is nothing but f star g of t. So this is what we are looking for. Now we have to use the technique of convolution onto this particular function. So that's exactly what we are going to do now. Now, using this formula, I can rewrite this as integral 0 to t. Now, my f of t is sine t. So, from here, f of t negative u can be rewritten as sine of t negative u. So, this is going to be my sine of t negative u times g of t. My g of t is cos of t. So my g of u is going to be my cos u. So we can write that cos u times du. Now we have obtained this. From here we can use compound angle formula. So what I'm going to do is I'm going to use this formula. So we know that half times, in fact, let me just use this in this fashion. We know that sine of a times cos of b is equal to half times sine of a minus b. This is a very important formula. Positive sine of a positive b. So if you were to expand this, you will get back this. So I can just show you that. Why am I writing this? So this is equal to half of, now sine of a minus b is going to be sine a cos b minus cos a sine b. Positive sine of a plus positive b is going to be sine a cos b positive cos a sine b. Right. Now sin A cos B, sin A cos B, these two can be added. Negative cos A sin B, positive cos A sin B, these two can be cancelled. So what do you get? You get 2 times sin A cos B, and that is product multiplied with 1 over 2. So 2 gets cancelled, giving you sin A cos B. So that is why this is a very important formula. So what exactly are we doing? We're connecting a product with a sum. Now why is it important? Specifically in integration, whenever you have trigonometric functions or exponential functions, one of the easiest way to solve them is to convert the product form into sum form. So that is simple as that. Now we have got sine of t minus u times cos of u. So let me rewrite that. Now sine of t minus u times cos of u. Now my a is t minus u, this is my a, my b is cos u. So I'm going to rewrite this as half of sine of my a t minus u, and my b is cos u, I mean u, followed by positive sine of my a is t minus u and my b is u. So let me have it like this, my b is u. So this is going to be rewritten as 1 over 2 times sine of t, negative u will give you negative 2u, positive negative u positive u, this can be cancelled, giving you sine of t. So wherever I see sine of t minus u times cos of u, I'm going to replace this. So let's go over here. So if I were to take this as 2, I'm going to say therefore 2 can now be rewritten as integral 0 to t, this is 1 over 2 times sine of t negative 2u positive sine t. Now this has to be multiplied with my du. Now I'm going to rewrite this as, now you got a half there, so I can take the half out and rewrite this as integral 0 to t sine of t negative 2 times u times du positive 1 over 2 times integral 0 to t sine of t times du. So this is what we have got. In fact, okay, that's okay. I place a parenthesis. That's fine. So now we will have to integrate this and then add it up with the integrated value of this. So to integrate this, what I wish to do is I would like to consider integral 0 to t sine of t negative 2u times du. Now use the function here. So I'm going to say let t negative 2u be equal to some p. So I differentiate this left hand side, so I get negative 2 times du is equal to dp. I want only du, so du is equal to dp. I bring the 2 down, in fact I'm bringing negative 2 down, so it's going to be negative 1 over 2. So this is the substitution that I have to use. So hence what happens, this is equal to integral, so I'm just drawing a line here, probably I will take this as 4 or 3. So hence this thing integral, I'm not going to touch the integral limits, so let it be like that. In fact I'm not going to place anything there. So this is going to be sine of t negative 2u, that's going to be p, and du is going to be dp divided by, in fact multiplied with 1 over 2 with a negative sign. So place that 1 over 2, place the negative sign. Now if you were to integrate sine p, this is going to be negative cos p. Of course there is a 1 over 2 there, but there is a negative sign there, so place that. Now this can be rewritten as 1 over 2 cos p. But what is p? P is nothing but t negative 2u. Now the limits, what are the limits? The limits are 0 to t, because I've now brought them back to the original t minus 2u. So now I can substitute the limits. So if I were to substitute the upper limit, so this is going to be cos of t negative 2 times t, negative cos of t negative, u is 0, so you place it there. So this is going to give you 1 over 2 times cos of t negative 2t, that's going to be negative t, and this is going to be negative cos of t. So this is what you have got. Now you can rewrite this. This is going to be 1 over 2. Now cos is an even function, so cos of negative t is going to be cos t followed by negative cos t. Now clearly you can see cos t negative cos t, they get cancelled, so giving you 0. So the value of the integral is 0. So clearly this vanishes. So I'm not going to do anything now. I need to just first get this quantity out of my way. So now I'm going to say consider integral 0 to t sine of t times du. Now this is a constant, so I can rewrite this as sine of t integral 0 to t times du. Now this is equal to sine of t, integral of du will give me u, the limits are 0 to t, so this is equal to sine of t, substitute the upper limit minus the lower limit. So this one is going to be t times sine of t. So this is what you have got for this. Now I need to take all these values and substitute it in 3. Okay, so hence my 3, I can rewrite 3 as, in place of the first quantity this is 0, but there is a half there, it doesn't matter, right? So half times 0 is going to be 0, but the second quantity is going to be 1 over 2 times, and in place of integral 0 to t sine t du, you will have to substitute t times sine t. So this is going to be t times sine t. So this is the value that you have got, and this is the solution. So this is the right point to stop. Students, we have given a very simple question to find the Laplace inverse of 1 over s times of s squared positive 1. Now I would be using convolution to solve this, so I would rewrite this as 1 over s times 1 over s squared positive 1. Then I will rewrite it as L inverse of 1 over s asterisk L inverse of 1 over s squared positive 1. I am actually performing the convolution. Now L inverse of 1 over s, this is going to be equal to 1. So that has to be convoluted with L inverse of 1 over s squared positive 1. That is going to be my sine t. Now you can take f of t to be equal to 1 and g of t to be equal to sine t. Now if you want to convolute f star g of t, I'm going to be using integral 0 to t f of t negative u times g of u times du. Now this is also the same if you were to reverse this. Now I'm going to show you that the solution is not going to change at all. So even if I have to perform the reversal of these functions, instead of taking f of t to be 1, if I were to take f of t to be equal to sine t, still it will be, solution is going to be the same. Now f of t is 1, so f of t minus u, let me just write that down here. f of t is equal to 1, and f of t minus u will be the same 1. There wouldn't be any change. And g of t is sine t, and g of u is going to be sine u. So therefore, so let me write one more step. Therefore L inverse of 1 over s asterisk L inverse of 1 over s squared positive 1. The convolution of this is, we have already got this. We have got this as 1 star sine of t, and if you want to evaluate this function, this is going to be integral 0 to t f of t minus u, that's going to be 1 times g of u, that's going to be sine u times du. So this is going to be equal to, you have to integrate sine u. Integral of sine u will give you negative cos u, and the limits are 0 to t. Now I substitute the upper limit, I get cos of t. I substitute the lower limit, it's going to be negative and negative, it's going to be positive, so it's going to be cos of 0. So this is going to be negative cos t. Cos 0 is 1, so you get 1 there. I can rewrite this as 1 negative cos t. So what is this? This is this, but what is this? This one is actually the original function. So this is going to be Laplace inverse of 1 over s of s squared positive 1. This I did solely by convolution. So simple. Now just to show you that convolution is commutative, what I wish to do is, now instead of taking f of t is 1, I'm going to take f of t is equal to sine t, and g of t is equal to b as 1. So from here the convolution is, I'm going to apply this convolution, f star g of t is equal to integral 0 to t. It's not f of t minus u, I'm going to be using g of t minus u with f of u times du. So this is what I'm going to be using. So from here, if I were to apply a g of t minus u, g of t minus u is 1, and f of u is going to be sine u du. So if you were to integrate, you are going to get negative cos u, and the limits are 0 to t. That's it. So the same value will be obtained. It doesn't matter. So that's the reason I used to say that convolution is commutative. So this is the end of solution, students. Students were given this question. We expected to find the Laplace inverse of 1 over s squared positive 1 times s squared positive 25. Now I would be rewriting this as Laplace inverse of 1 over s squared positive 1 times 1 over s squared positive 5 squared. Now this can be further rewritten as L inverse of 1 over s squared positive 1 asterisk L inverse of 1 over s squared positive 5 squared. So if I'm able to achieve the convolution of these two quantities, solution is done. Now L inverse of 1 over s squared positive 1 is sine of t asterisk 1 over s squared positive 5 squared, that's going to be sine 5 times t with a product multiple of 5. So I've got two functions. I can take one function as sine t and the other, in fact I can take one function as f of t, the other function being g of t. It's going to be 1 over 5 times of sine of 5t. Now if you've got a convolution to be performed on two functions, f star g of t, then it's 0 to t f of t minus u times g of u times du. Now from here I can find f of t minus u, which is going to be sine of t minus u, and also I can find g of u, which is 1 over 5 times sine of 5u. So therefore the convolution of these two functions is written as integral 0 to t f of t minus u is sine of t negative u times g of u is going to be sine of 5 times u as a 1 over 5. I can place that 1 over 5 here times du. So this is what we have got. Now we know a compound angle equivalent formula for this, so which is nothing but 2 times of sine A sine B is equal to cos of A minus B negative cos of A positive B. Now I'm going to show you how these two are connected. Now cos of A minus B is cos A cos B positive sin A sin B negative cos of A minus B is cos of A positive B is cos A cos B. This is positive, so it's going to be negative here. So negative sin A sin B. Okay, a parenthesis. So this is going to be, I'm going to rewrite this as cos A cos B positive sin A sin B negative cos A cos B positive, because negative times negative is positive, sin A sin B. Now cos A cos B, negative cos A cos B, these two can be cancelled, these can be added, so it's going to be 2 times of sin A sin B. Now on the left side I got 2 times sin A sin B, so that's what I'm getting, 2 times sin A sin B. So what I would do is, instead of sin A sin B, I can now write, this means my sin A sin B is going to be half times of cos of A minus B negative cos of A positive B. So I can use this formula safely, right? But my A is t minus u and my B is 5u here. So if I were to substitute this, so all of these things are for your understanding. So therefore consider sine of t minus u times sine of 5u. So A is t minus u and B is 5 times u. So this would mean my sin A sin B is going to be 1 over 2 times of cos of A is t minus u followed by a negative sign, my B is 5u, followed by negative cos of my A is t minus u, followed by a positive sign and 5u. So this is what we've got. I can rewrite this as half times cos of t negative u negative 5u. This is going to be negative 6u, negative cos of t negative u positive 5u. That's going to be positive 4u. So I will have to substitute instead of this. So if I were to take this as 2, hence 2 becomes, so this is equal to 1 over 5 times integral 0 to t. 1 over 2 is there, so I can have that over here as 2 times, and this is cos of t negative 6u negative cos of t positive 4 times u times du. Now I can rewrite this as 1 over 10 integral 0 to t cos of t negative 6u times du negative integral 0 to t cos of t positive 4u times du. So this is what we have got. Now we will show you, in other words, let's see how to integrate this one. So consider integral cos of t negative 6u times du. Limits are 0 to t. So I'm going to take, let t negative 6u be equal to sum p. I differentiate 6 times du is equal to dp. So that means du is equal to negative 1 over 6 times dp. This is what I've got. So hence integral 0 to t cos of t negative 6 times u times du is equal to integral. I'm not going to touch the integral, just I'm going to substitute t negative 6u to be as p and the du to be as dp over 6 with the negative sign. So if I were to integrate this, this is going to be sin p. I get a 1 over 6, I get a negative sign, and I can rewrite this as negative 1 over 6 of sine of my p is t negative 6u, and the limits are 0 to t. That's fine. So all that we have to do is multiply this component with 1 over 6 with the negative sign and then integrate. Of course the integration of cos is going to be sine, so that's what we have done here. So I substitute the upper limit, so it's going to be negative 1 over 6. Substitute the upper limit is going to be sine of t negative 6 times t followed by negative sine of t negative. In place of u, you got to substitute, so it's going to be negative 0. So this is going to be negative 1 over 6 sine of t negative 60. That's going to be negative 5t, and followed by sine of t. Now sine is an odd function, so you get negative 1 over 6 with the negative sine of 5 times t, negative sine t. So that's going to be negative negative positive 1 over 6 times. Okay, so you have this. So this is one component, so you have to have the other component. So probably I can take this as 3. So now we will have to consider integral 0 to t cos of t positive 4 times u times du. Now you can directly integrate this without, because there isn't any negative sign to be worried about. So this is going to be sine of t positive 4 times u. The coefficient of u is 4, so it's going to be 1 over 4 here. The limits are 0 to t. So I apply the limits, I get 1 over 4 times sine of t positive 4t minus sine of t positive 0, because you got to substitute this value 0. So this will give me 1 over 4 times of sine of t positive 4t. That's going to be my sine of 5t. This is going to be negative sine t. So I got this value, I got this value. So I need to put these things into the original 3. So therefore my 3 is going to be 1 over 10. In place of this I need to substitute this. So this is going to be 1 over 6 of sine t positive sine 5t. So I'm going to rewrite it like this: 1 over 6 times sine t positive 1 over 6 times sine 5t. You have a negative sign, I need to substitute this. So 1 over 4 times sine 5t and negative. Since there's a negative and there's a negative, that becomes positive 1 over 4 times sine t. So this is what I've got. Now I can club these things. I can club these two things together. So, and these two things together. So this is going to be 1 over 10 times. I take 1 over 6. In fact, if I take 1 over 6 out, in fact I need to take sine t out. So this is going to be 1 over 6 positive 1 over 4. Right, clubbing this with the sine t, and then I would have to take sine 5t out. So it's going to be 1 over 6 negative 1 over 4 of sine 5t. So this is how it's shaping up. So this is equal to 1 over 10 times. If I take the LCM as 24, it's up to you. You take whatever value you want, because you need to simplify this. So you can be simplified in many different ways. So this is going to be 4 positive 6 times sine t, and this is going to be 4 negative 6 times sine 5t. So I can rewrite this as 1 over 10 times 10 divided by 24 sine 5t. This is going to be negative, so it's going to be 2 over 24 times sine 5t. Of course you can simplify this. Now you can, if you want to bring this 10 inside, you can do that. So if you bring the 10 inside, this is going to be 1 over 24 times sine t, because 10 and 10 can be cancelled. And if you are bringing this 10 inside, clearly 2 divides here 12 times, so 12 times 10, that's going to be 120. So 120 times sine phi t. So this is the solution to this question. So it's got a little bit of process that is involved, which you have to do meticulously. Students, we're given this question to find the Laplace inverse of 1 over s squared positive 1 times s squared positive 4 times s squared positive 9. Now this is a beautiful question. It's beautiful for the simple fact that it is a denominator which is very impressive. Now what I would do is, foremost, I would like to consider the Laplace inverse of 1 over s squared positive 1 times s squared positive 9. So this I'm going to be rewriting it as Laplace inverse of 1 over a squared positive 1 times 1 over a squared positive 9, which can be written using the means of convolution as Laplace inverse of 1 over a squared positive 1 asterisk Laplace inverse of 1 over a squared positive 9. Now this is straightforward, but before I could place the Laplace inverse of this, I would like to rewrite this just for the sake of understanding, right? So this is going to be Laplace inverse of 1 over a squared positive 1 asterisk Laplace inverse of, I would like to write 9 as 3 squared. Now Laplace inverse of 1 over a squared positive 1, that is going to be sine t. It's straightforward. Asterisk Laplace inverse of 1 over a squared positive 3 squared, that's going to give me sine 3t with 1 over 3. So I would like to apply convolution for these two functions. Now just for the sake of refreshment, if I have two functions f star g of t, and if I am trying to convolute this is going to be integral 0 to t f of t negative u times g of u times du. This is the formula that we would have to use. So I can clearly take, depends on what you like, whether you want to take this as f of t or this as f of t, it doesn't matter. So what I would do is f of t is equal to sine t, and my g of t is 1 over 3 times sine of 3 times t. Now we're going to apply convolution. So if I've got f star g of t, this is going to be integral 0 to t f of t minus u times g of u times du. So this is what we are going to use as a formula. So f of t is this, so f of t minus u is going to give me sine of t minus u, and g of u is going to be 1 over 3 times sine of 3 times of u. So if we are applying convolution, so hence f star g of t is equal to integral 0 to t f of t negative u, that's going to be sine of t negative u, g of u is 1 over 3 times sine of 3 times u times du. I can rewrite this as 1 over 3 times integral 0 to t sine of t negative u times sine 3u times du. Now this is a product form, so I will either write to I have to convert this into a sum and or difference using the compound angle. Now I will be using this formula. So we know that sine A sine B, 2 times sine A sine B is equal to cos of A minus B negative cos of A positive B. Now I can show that the left side is equal to right side just for sake of confirmation. If I were to expand this is going to be cos A cos B negative sign, so it's going to be positive sine A sine B negative, so this is going to be cos A cos B. I would say since it's positive I will have a negative sign, so it's followed by a negative, but there is a negative sign already, so that would mean I will have a positive sine A sine B. Now negative cos A cos B and positive cos A cos B can be cancelled, giving me sine A sine B added with sine A sine B, so that's going to be 2 times sine A sine B. What is that? That's nothing but my left hand side, so this formula is absolutely correct. So that's the reason I would be employing this difference formula for this component sine of t minus u times sine of 3 times u. Now clearly my A is t negative u and my B is 3 times u. So if I were to substitute this sine of so let me write that down, sine of t negative u times sine of 3 times u can be rewritten as, we don't have a 2 there, so I need to bring the 2 here, so 1 over 2 times cos of my A is t negative u followed by a negative sign, my B is 3 times u followed by a negative sign, and then my cos is my A is t negative u followed by a positive sign, my B is 3u. So this is what I have got. Now this is equal to 1 over 2 times u negative 3u. So that's going to give me cos of t negative 4 times u followed by negative cos of t negative u positive 3u. So that's going to be t positive 2u. So this is what is my outcome for this component. So if I were to take this as 2, so hence I can rewrite 2 as 1 over 3 times parenthesis integral 0 to t. In place of sine of t negative u times sine of 3 times u, I'm going to substitute this. So this is going to be 1 over 2 times cos of t negative 4 times u negative cos of t positive 2u. So this is what I've got. This has to be multiplied with du. Now I got a quantity of 1 over 2. I can take that out. So that will be 1 over 6 parenthesis. So I need to integrate 0 to t cos of t negative 4 times u times du. That's fine. Followed by a negative sign integral 0 to t cos of t positive 2u times du. Now this can be rewritten as 1 over 6. Now this is cos of t negative 4u. With the u I got a coefficient of negative 1 over 4. So I need to multiply it by negative 1 over 4. Integrating cos will give me sine. The argument is t negative 4u. Simple as that. But the limits are 0 to t. So you can substitute that. Followed by negative, I need to integrate cos of t positive 2u. So that's going to give me 1 over 2 times sine of t positive 2u. The limits are 0 to t. So that's it. Fair enough. Now if you were to I want to place 1 over 6 as it is. So I'm substituting the upper limit. So it's negative 1 over 4 sine of t negative 4 times t negative sine of t negative 0. This is for this quantity, followed by negative 1 over 2. Substitute the upper limit, sine of t positive 2t negative sine of t, because u is 0. Right? Now this is equal to 1 over 6 negative 1 over 4 times t negative 4t. That's going to give me sine of negative 3t followed by negative sine of t. Okay, so that's for this part. Now negative 1 over 2 times of sine of t positive 2t. That's going to give me sine of 3t negative sine of t. Now rewriting negative 1 over 4, this is already the sine is an odd function, so sine of negative 3t would be negative sine of 3t, so that's going to be positive. So it's going to be 1 over 4 times sine 3t, and we have a negative sign, negative, that's going to be positive 1 over 4 times sine t, and negative 1 over 2 times sine of 3t, and this is going to be positive 1 over 2 times sine t. So this is what I've got. So now I need to simplify this. Now I can add these two together, and I can add these two together. So let's do that. So I want to just use this space over here. I know it's a little bit restricted. So 1 over 6 I'm taking it out. So I will take sine 3t out. So that's going to be 1 over 4 from this side, and followed by negative 1 over 2 times sine 3t. Okay, and then I have to simplify this. So followed by positive 1 over 4 positive 1 over 2 times sine t. So this is what I've got. Now if I were to take the LCM as 4, this would give me 1 negative 2, which is negative 1 over 4. For this one is negative 1 over 4. So I can rewrite this as 1 over 6 So as I mentioned to you, I'm taking 4 as the LCM. So if I were to take 4 as the LCM, this will give me 1 negative 2. That's going to be negative 1 over 4 sine 3t. And as I mentioned to you, I take 4 as the LCM. So this would give me 3 over 4. So positive 3 over 4 sine t. So this is what I've got. Now I can rewrite this as 1 over 6 times positive value first. So 3 over 4 sine t, negative 1 over 4 sine 3t. So this is the convolution that we started off. Convolution of these two functions. Okay. Now just for sake of simplification, what I can do is I can bring this 1 over 6 inside. So that would mean 3 over 6 times 4 is 24 times sine t, negative 1 over 4 times 6, that's going to be 24, 1 over 24 sine 3t. Now 3 divides here 8 times, so I can have this as 1 over 8 sine t, negative 1 over 24 times sine 3t. If I were to take 1 over 8, I get sine t negative 1 over 3 times sine 3t. Okay, this is what I have. Now why did I do all this? Because we will have to use this result. So simplification is always a better way whenever we need to use this into solving a bigger problem. So let's move on. Now if you remember, we started off on our quest to solve this question, and the original question was of this fashion. So 1 over s squared positive 1 times s squared positive 4 times s squared positive 9. This was the original question, and we started off rewriting this original question in this fashion. Say 1 over s squared positive 4 times 1 over s squared positive 1 times s squared positive 9, and then we can actually have this to be as 1 over s squared positive 4 asterisk L inverse of 1 over s squared positive 1 times s squared positive 9. Now in the just a few minutes ago we were able to achieve this. So what did we do? We achieved L inverse of 1 over s squared positive 1 times s squared positive 9. Of course we applied a convolution, and then we arrived at a solution for this as 1 over 8 times sine t, negative 1 over 3 times sine 3t. Okay, fair enough. So this is done. But what is this? L inverse of 1 over s squared positive 4. What is that? I can always rewrite this as L inverse of 1 over s squared positive 2 squared. So which is equal to L inverse. Of course I don't need to. I can directly get the transform. So this is nothing but sine 2t, and of course there has to be a multiple of 1 over 2. So this is what is the Laplace inverse of 1 over s squared positive 2 squared. Now we will have to use these two things. So this is equal to 1 over 2 times sine 2t convoluted with 1 over 8 times of sine t, negative 1 over 3 times sine 3t. So we need to apply convolution to this. So I would be taking my f of t to be equal to 1 over 2 times sine 2t, and my g of t is 1 over 8 of sine t, negative 1 over 3 times sine 3t. Now f of t negative u is 1 over 2 times sine of 2 times of t negative u, and my g of u is 1 over 8 times of sine u, negative 1 over 3 times of sine 3 times u. So therefore f star g of t is equal to integral 0 to t f of t negative u times g of u times du. So this is going to be integral 0 to t 1 over 2 times sine of 2 times of t negative u times 1 over 8 of sine of u minus 1 over 3 times of sine 3 of u, and this has to be multiplied with du. So what we can do is we can take 1 over 8 and 1 over 2 out, so that's going to be 1 over 16 integral now 0 to t times. So we've got sine of 2 of t negative u, and that has to be multiplied with sine u negative 1 over 3 times sine of 3 times u. So this is what we have got. Now I can distribute these things, so let me just place the parenthesis. So this is going to be equal to 1 over 16 times integral 0 to t sine of, in fact I can take the 2 inside, so it's going to be 2 times t negative 2 times u times sine u. I want to bring in the du, followed by negative 1 over 3 times integral 0 to t sine of 2 times t negative 2 times u times sine of 3 times u, and you have a du there. Now we know that 2 times of sine a sine b is cos of a minus b negative cos of a positive b. I've already proved this to you, and I can rewrite this as, in fact, sine a sine b is 1 over 2 times cos of a minus b negative cos of a positive b. So if you were to expand this, and you can clearly see that the cos of a cos b will be cancelled with cos a cos b, but sine a sine b will remain. So what we will do, we will use this result. So this one ends, I can rewrite this, ends sine of 2t negative 2 times u times sine of u. I can rewrite this by using this. So I'm going to take a is 2t negative 2u, and my b is equal to u. So this is going to be equal to 1 over 2 times cos of a 2t negative 2u, followed by negative b negative cos of a 2t negative 2u, followed by my b. So this is equal to 1 over 2 times cos of 2t negative 2u negative u, so it's going to be 2t negative 3u, followed by cos of 2t negative 2u positive u, so it's going to be 2t negative u. So instead of this I would be using this. Okay, fair enough. Now comes the next part. So we will have to use now sine of 2t negative 2u times sine of 3u becomes, so we need to know what happens to this. So my a is 2t negative 2u and my b is 3 times u. So if I were to use this, this is going to be 1 over 2 times cos of a, so 2t minus 2u minus b negative cos of a 2t negative 2u positive b. So this is 2t minus 2u positive b. My b is 3u. So I can rewrite this as 1 over 2 times cos of 2t negative 2u negative 3u. That's going to be cos of 2t negative 5u negative cos of 2t negative 2u. This is positive 3u, so that's going to be 2t positive u. So we've got this, we got this. So if I were to take this as, say, sum 3, so hence 3 becomes, so I have to start with 1 over 16. Instead of this I will have to replace this. So integral 0 to t 1 over 2 times cos of 2t negative 3u negative cos of 2t negative u, followed by negative 1 over 3 times. Instead of this, I will have to replace this. So it's going to be 1 over 2 times cos of 2t negative 5u negative cos of 2t positive u. This is what I've got. So times du. Of course, I need to have a du. Okay, so we will have to integrate this. Now I'm going to rewrite this as 1 over 16. This quantity times the differential operator. So 0 to t 1 over 2 times cos of 2t negative 3 times u times du negative 1 over 2 times integral 0 to t cos of 2t negative u times du negative, I can take this 1 over 3 inside, so 1 over 6 times integral 0 to t times cos of 2t negative 5 times u times du positive 1 over 3 times integral. In fact, this should be 1 over 6. So when we bring in negative, negative, positive, that's fine, 0 to t, and this is going to be cos of 2t positive u times du. So this is what we have got. So that's fine. So let's integrate this. So this is going to be 1 over 16, 1 over 2 times, I integrate this, I would get sine of 2t negative 3u, coefficient of u is negative 3, it's going to be 1 over 3 with a negative sign. The limits are 0 to t, so we can place the limits. So probably I'll place the limits like this, 0 to t, followed by negative 1 over 2. Integration of this will give me sine of 2t negative u, coefficient of u is negative, so place that. The limits are 0 to t, followed by negative 1 over 6. The integration of this would give me sine of 2t negative 5u, coefficient of u is negative 5, so it's negative 1 over 5. The limits are 0 to t, positive 1 over 6 times, integration of this would give me sine of 2t plus u, quotient is 1, so the limits are 0 to t. So this is what I've got. Now this is 1 over 16 times 1 over 2 times 1 over 3 with a negative sign, 1 over 6. I substitute the upper limit, so that's going to be sine of 2t negative 3t for the first component, followed by negative sine of 2t minus 0 for the next component. So this is for one part, followed by negative 1 over 2 times negative negative positive, that's fine. I substitute the upper limit, so that's going to be sine of 2t minus t negative sine of 2t minus 0, that's for this part, followed by negative negative positive, so it's going to be 1 over 30 times sine of 2t minus 5t for the first part, negative sine of 2t, okay, 2t minus 0, that's okay. So followed by positive 1 over 6 times, substitute the upper quantity, sine of 2t positive t negative sine of 2t positive 0. So that's what I'm getting. Now this is equal to 1 over 16 times negative 1 over 6. sine of 2t negative t, that's sine of negative t. Sine is an odd function, so I can write it as negative sine of t. This is negative sine of 2t, that's fine, followed by 1 over 2 times sine of 2t negative t, that's going to be sine t, sine of 2t, followed by 1 over 30 sine of 2t negative 3t, negative 5t, that is sine of negative 3t, so that's going to be negative sine 3t, followed by negative sine 2t, that's fine, followed by positive 1 over 6 times. Now sine of 2t plus t, that's sine of 3t negative sine of 2t. So we got that. Okay, so that's this is sine of 2t. So this is equal to 1 over 16 times negative negative positive, so 1 over 6 times sine t, negative negative positive 1 over 6 times sine 2t, positive 1 over 2 times sine t, negative 1 over 2 times sine 2t, negative 1 over 30 times sine 3t, positive 1 over 30. This is not positive, it's negative. Negative 1 over 30 times sine 2t, and positive 1 over 6 times sine 3t, negative 1 over 6 times sine 2t. Okay, this is what we have got. Now we need to take things common, so I will start with sine 3t first. So sine 3t, sine 3t, so this is equal to 1 over 16 times, I'm taking sine 3t out, so I will get 1 over 6 negative 1 over 30. Okay, that's fine. Next sine 2t, so plus sine 2t, plus sine 2t, so I have a sine 2t, I start with sine 2t, so 1 over 6, I have a sine 2t. In fact, these two things can be cancelled, right? So I have a sine 2t with 1 over 2, and I have a sine 2t. I have a sine 2t here, I have a sine 2t here. So 1 over 2 negative 1 over 30. So anything else? Okay, that's fine. So this is done, this is done, this is done, this is done, this is done. I have a sine t now. So I'm taking sine t out, and I have a 1 over 6 and a 1 over 2. So that's it. So if I were to take the LCM for this, I think I will use this space here. So 1 over 6 negative 1 over 30, I'll take 30, and this will give me 5 negative 1, right? 6 5 1, so this is going to be 4 over 30, which is nothing but 2 over 15. So this is 1 over 16 times 2 over 15 times sine 3t, positive. Now let me use this space here. 1 over 2 negative 1 over 30, the LCM 30, 15 negative 1, 14 negative 30, 7 over 15, right? This is 7 over 15 times sine 2t, and the LCM is 6. This is 1, 3, 4 over 6, so 2 over 3. So this is 2 over 3 times sine t. So this is the solution for the question that we have seen. So thank you, students.